This video is an introduction to using Solver in Excel 2010. Solver is a utility similar to GoalSeek. It has the capability to solve the same kinds of problems that GoalSeek can, as well as more complex ones. Solver is located on the Data tab of the ribbon, in the Analysis panel. As you can see here, it's not listed. Solver is automatically installed with Excel, but it's not automatically activated. To activate Solver, you go to File, Options, Add-ins, Manage Excel Add-ins, Go, and then you select Solver Add-in. As you can see, Solver is now in the Analysis panel of Data tab. I have an example problem set up to show you how to use Solver. This example problem has 3 questions. The first is, using the provided spreadsheet, find out how much you would weigh on Jupiter. This first question actually does not use Solver, but it'll introduce you to how I've set up this worksheet. Here, we need to first enter a weight. I'm going to enter 155 pounds. It automatically updated the weight in kilograms and the gravitational force generated by Earth. Now we need to include the planet mass and radius of Jupiter. The third spreadsheet on this workbook has the data from the planets. The data from Jupiter is in this row. I'm going to highlight this and paste it over here so I can read it more easily. So this first value here is the mass, and the second one is the radius. As you can see, the spreadsheet has updated again. Now it has included the converted weight in kilograms and pounds, as well as the planet density. It also showed here how much more you weigh on Jupiter than you do on Earth. So on Jupiter, someone who weighed 155 pounds would weigh 392. The second question is, what is the radius of the planet that would make you weigh the same as you do on Earth if it had the same density as Pluto? So what we need is the density of Pluto to begin with. So we go back here, we have to change these values to make the density equal to Pluto, so we find out what that is. We go to extra data, Pluto is right here, but the density is already listed. So instead, we can just copy this and paste it for reference over here. So here is the density of Pluto. We need to find out what the radius would be of a planet to make this value the same as this value. So what we do, now that we have the density of Pluto over here, is we highlight and copy this number, and then we start Solver. The Solver screen, as you can see, is rather large, so it's covering up the spreadsheet. While I'm showing you this example, I'm going to have to continually move it off the screen to show you what's happening on the spreadsheet itself. So first we need to set the objective. This is the value that we want to change, and that would be the value in F8, which is this mass here. We want this value to equal this value here. So if we set F8 to the value of 155 pounds, then it's going to cause changes until it can get this value to match that one. But we need to tell it what to change. And that's here, by changing the variable cells F10 and 11. Because although we're just looking for the radius, we want to allow the mass and the radius to change, because we need the density to update. And the density is a constraint. So that's in the Subject to Constraints box here. We select Add Constraint, we pick the cell reference as here, equal to, and the value we copied previously, which is the density of Pluto. If we select OK, it'll add the constraint in this box. Now that we have everything set up here, we select Solve, and Solver goes through and solves the solution for us. So I'm going to move this off the screen so you can see what it's come up with. Here you can see that the weight is now 155 pounds, and it did it by changing the mass and the radius. So in the Solver box, you can either select to have it keep the Solver solution or to restore the original values. I want to keep the original solution. We would like to see how much these have changed from what it used to be. If you remember, the original values were for Jupiter. So I'm going back here and copy these back. So Jupiter originally had a mass of 1.9 times 10 to the 27th, and it's gone down from that to 4.5 times 10 to the 25. So here the planet radius has decreased from 71 million to 17 million. So both the mass and the radius had to decrease. But compared to Pluto, the mass has gone up and the radius has gone up as well. So the radius here is the value that answers that question, and this is in meters. The third question is how much would you have to weigh on Mercury to weigh the same as you do on Earth? So if we go back here, now what this question is asking is what would this weight have to be on Mercury to make the pounds here equal to that 155? So first we need to get the information for Mercury. The mass of Mercury goes here and the radius goes here. So on Mercury, if you weighed 155 pounds, you would now weigh 58.5 pounds. We're going to start solver again, and as you can see, it kept the values from the previous solution. I'm going to go ahead and delete these so we can start all over. We need to set our objective, which is actually the same spot here, to the value of 155, except this time the only thing we're changing is the cell B7, which was the original weight. Everything else remains the same, so we're not going to have to add any constraints. We clicked solve. Then you would have to weigh 410 pounds on Earth to weigh 155 pounds on Mercury.